Hi, I'm Josh, a Java developer. This is the first of a series of videos where I'm learning better techniques for unit testing and fuzz testing in my test automation approaches. Remember, if you like this content, please like and subscribe our videos on YouTube and our Twitter. As a Java developer, one of the key problems that I face on a regular basis is being able to write and understand good code. This might be code that I've written myself, or it could be code coming from someone else on my team or from a project that I'm working with. So in this case, understanding what my code does and understanding how to make it better are critical for success. So one thing that is very helpful for understanding what your code does is unit testing. Being able to write and execute good unit tests gives you all sorts of great ways to understand your code. You can see what your code looks like when it's running. You can interact with your code in place without deploying or building an entire code base or application. And you can also identify certain bugs or certain basic issues that might arise over the course of writing code. However, writing good code and writing unit tests might not be sufficient. There are certain kinds of bugs and issues that arise that good unit testing practices may miss. So, to help with this problem, I'm investigating and learning about fuzz testing. Fuzz testing is a classic test automation technique where a bunch of inputs are generated semi-randomly that might be semi-valid and are inputted into a function under test or a method under test or so on. You can fuzz at various levels, but I'm going to focus mostly on fuzzing at the unit level, right? Understanding what my class is doing or what my little bit of code that I'm working on in isolation is doing. Fuzz testing allows me to explore and reveal issues that I might not have even thought of. In contrast with unit testing, where I have to, as the developer, sort of understand what my code is doing and understand what I'm looking for. The two can be used very well in conjunction with each other to better write code and to better understand what your code is doing and find all those nasty bugs that just keep slowing you down. So let's think of an example. One of the most commonly used SQL libraries with things like Spring or other Java applications is HyperSQL. So HyperSQL has been revealed to have a major security issue, a major CVE with a critical score. What does this mean? This means that in the library, which is maintained by the HyperSQL team, it's possible to trigger something called a remote code execution. This means a malicious actor can insert a class into your code or insert a class into your Java class path, which allows an attacker to trigger remote code on like a given machine. So if you've deployed your Java application somewhere, it's possible to insert a malicious piece of code that executes arbitrary software on that system running that Java stuff. So this is bad. This is a high security issue, and it may not be something that the HyperSQL team was able to find using their conventional methods. However, it was found using fuzzing techniques, and that's something that I'm going to be showing in this video.
Let's look at this example of finding a vulnerability in HyperSQL, a very popular Java utility. I was able to replicate a remote code execution in HyperSQL with a severity score of 9.8 out of 10. This is a link to the severity itself, noted as a CVE in the CVE database. So 9.8 out of 10 means that this vulnerability is very severe. This project, which is the second most popular SQL database used in Java with over 100 million downloads to date, is used for Java deployment, development, and testing of database applications. HyperSQL is used by over 3,000 Maven packages, including mainstream projects such as LibreOffice, JBoss, Log4j, Hibernate, and Spring Boot, as well as being used in various enterprise Java applications. So this vulnerability is a big deal, but it only took me a few minutes to find it. For finding this vulnerability, I used CI Fuzz CLI, an easy-to-use fuzz testing tool that enables you to integrate and run JUnit-compatible fuzz tests directly from your command line. I worked with this tool because it's intuitive to use, and it allows developers to set up and run fuzz tests with only a few simple commands. Plus, it works pretty well. Honestly, it's a good tool. I really like it. You should try it out. So if you want to try it out, you should check it out on GitHub. Leave a star for this awesome project and all of its open source maintainers and team. They're a great team. You should just star it for us. And also fork and try it out. You can download right from here new releases for CI Fuzz. So here's my initial fuzz test. And if I simply run CI Fuzz, it builds my project, runs, does a little bit of fuzzing magic, and finds an issue. Easy peasy. In my next video, I will show you how to set up and run this fuzz test and similar fuzz tests in practice. that's all for today. Check out the descriptions in this video. There you can find a number of cool tools and resources that you can use to help you get into fuzz testing yourself.